Find the antiderivative of the following function. So we go right into examples, because that's all this section is basically examples. The way I'm going to teach you, there's actually two ways of doing it. I think the way I'm going to teach you is a little bit easier. Okay. What happens in a U substitution is you select an expression in your integrand and rename it U. Because the way part A is written, we would have to square that out, distribute the 4, and then break it up into 3 integrals. But U substitution goes a little bit faster. B and C, on the other hand, we don't know how to do that. C especially, we'd have to FOIL that out 8 times, then distribute the 5x and break it up into 9 integrals. Way too much fun. So instead, U substitution is good. Notice in each case, we have something, a function inside of a function. So those are all compositions of functions because you have a function inside of a function. So that's where U substitution comes in. So in part A, we're going to let U be 4x plus 1. I'll explain later why we let U be this value. Not yet. We're now going to take the derivative of U, but we're not going to write U prime. Remember we had that other way of writing it, du dx. Instead of dy dx, we have du dx. So what's the derivative of U with respect to x? 4. And now I want you to solve for dx. Well, the fastest way to solve for dx is just switch these two. It'll always work. In other words, what happens is you'd multiply both sides by dx, and then you would divide by 4. Or you can do that in one line, and these two just switch. We're going to be doing that a lot in this section. So you would say du over 4 equals dx. So let's rewrite our integral, because this was all side work. This 4, we're going to leave alone. We're going to keep it right there, 4. 4x plus 1, what do we call it? U. So notice, what are we doing to that 4x plus 1 in the original integrand? Squaring it, so U squared. And now what is our new dx? du over 4? What happens to the 4's? They cancel. So we'll have now the integral of U squared du. And this puts us back in 15.1. What is the antiderivative of U squared with respect to U? Well, this is just your power rule. What's your N? 2, which is 1/3 U to the 3rd, and then plus C. It's gone, just like when after you integrate, the du and the integral goes away. But did we start with U? No, what did we start with? So put your U back in, and now you're done. So if we were to differentiate this, we'd have to use the chain rule. You'd have 3 times the 1/3 would make what? 1. You leave the inside alone, you take 1 off the exponent, which would make squared, and then you'd multiply by the derivative of the inside, which would be 4. And notice that's what we started with, because the derivative of a constant is 0. So U substitution undoes the chain rule, the composition of functions. How about part B? What should we pick our U to be? Let's just do the x cubed plus 5, because what is the derivative of x cubed plus 5? 3x squared. And is there a 3x squared in the integrand? Yeah. You don't want to include the square root, because then it would be 1/2 x cubed plus 5 to the negative 1/2 times 3x squared. That's too much. You just want to take the inside there, x cubed plus 5. Okay? So I'm not going to rewrite the problem to save on space. So we're going to say let U be x cubed plus 5. So that implies that du dx, what's the derivative? 3x squared. So if you were to solve for dx, what does that mean? Very good, du over 3x squared. Well, I will take your suggestion. We'll rewrite it as a 1/2 power. Okay. So let's rewrite it. X cubed plus 5, what did we call it? U. Dx is now, what happens to the 3x squareds? They cancel. After you have done a U substitution, your integrand needs to be all in terms of U. We can't have any x's left over. If you do, either that means you picked the incorrect U, or you have to do some more work. And we'll see that later on. So this is, again, another power rule. What's our n? 1/2. So we'll have 1 over 1/2 plus 1, u to the 1/2 plus 1. And then, plus Mediterranean. What is 1 over 1/2 plus 1? 2/3. U to the 3/2. Did we start with U? Terrible. Did we start with U? No. Put your U back in. So what's your final answer? To the plus to the 3/2 plus C. Does anyone have a good U to pick? So when you're at home, you might have to do some trial and error. So let me repeat it. You want to pick a U in such a way so that its derivative or a multiple of its derivative also appears in the integrand. Now I want you to think outside of the box. I never said it had to be an integer multiple. It could be a fractional multiple. Yep, U being x squared minus 7 is the best one here. And let's actually go through the problem. And you'll see the multiple. If U is x squared minus 7, what's the U dx? 2x. So solving for dx, we get u over 2x. So again, that's all side work. So that remember, the main goal of U substitution is to get the x's out of there. So 5x times u to the 8, and dx is du over 2x. So the main goal is to pick your u so that when you put it back in, there's no more x's left over. Well, notice the 5x is technically on the upstairs, and the 2x is on the downstairs, so what happens to those x's? And you get 5/2, because the x's just cancel. So that's what we wanted. That multiple I was mentioning was 5/2. What can we do with that 5/2? Show it a night on the town, bring it to the playground, put it in front of the integral. Put it on there. There you go. I don't know how you show 5/2 a good time. Let's find the antiderivative of u to the 8th. What's n? 8. So this would be 1 over 8 plus 1. U to the 8th plus 1. Plus c. So 1 over 8 plus 1 is 1/9. What's 5/2 times 1/9 without a calculator? 5/18 u to the plus c. But we didn't start with u. Put your u back in. Hooray!